All right, thank you. I'll just take a look at that today. All right, so let's go over that extra credit problem. And I think a lot of you guys figured out a very clever way to do it, which I liked. But yeah, but we'll go over it. So the idea was that I had a pool ball, or just some ball mass M, going at 5 meters per second, and it hits another ball. This is before the collision. And then after the collision, these two balls are moving. The first one is moving at an angle of 15 degrees with respect to the initial direction. And then this one, you don't know. My question was, what was this V vector? I think it was vector, right?
Yeah, vector 1 and vector 2.
And then this was, and then what was this vector? It just asks for speeds. Do you remember?
Yeah.
Okay. I'll give you guys the benefit of the doubt on that. Okay.
You have to find V1 and V2.
What's that?
You have to find V1 and V2.
Yeah,
Yeah.
V1
V1, V2.
Yes.
For some reason, I was thinking I was asking about vectors, but if you have the speeds correct, we'll be okay.
Okay, that's why I was confused.
I think you did both. Yeah.
I goes to his office to see if it was right, and then he goes, breaking the components and made me aware.
Did I confuse you?
Then made me do a lot more work.
Good. It's good for a person. All right, well, let's go ahead and see if we can do this. So, first of all, you guys came up with the brilliant idea that if you drew a triangle, that because momentum's conserved, I could have M, V initial. Let's call this V initial. So, V initial is this vector. MV initial would equal M V1 plus M V2. That's due to momentum conservation, right?
Yeah.
And if I divide through by an M, like this, I would get V initial is equal to V1 plus V2. And if, this is an I. And if I were to draw that, you could draw this out. V1 and V2 are two vectors, right? So if I add V1 like that, V2 like that, the resultant vector would be from here to here. That would be the V initial, right? That's what this kind of equation means graphically. That V1 plus V2 equals V initial. So that's what it means graphically. And then we said that if it's an elastic collision, what's the angle between V1 and V2?
90 degrees.
So that's a 90-degree angle if it's an elastic collision. That's because kinetic energy is conserved, so 1/2 M V initial squared is equal to 1/2 M V1 squared plus 1/2 M V2 squared. And if I divide through by 1/2 M, I get V initial squared is V1 squared plus V2 squared. That's Pythagorean theorem applied to this triangle. And that only holds for right angles, for right triangles. So that means that this has to be a right triangle here. Doesn't look like it, but that's okay. This angle was 15 degrees. And automatically you've already solved, almost already solved what the magnitude of V2 and the magnitude of V1 have to be, right?
Mm-hmm.
So this was the magnitude of this was equal to 5 meters per second. So V1 is going to be what? 5 meters per second cosine
Cosine of
15 degrees. See that?
Mm-hmm.
So this is my hypotenuse, the 5 meters per second. This would be the adjacent side to that 15-degree angle. V2 would be 5 meters per second sine of 15 degrees. Okay. And what would that be? Well,
Yeah, 1.29, I mean 92, and then 1.293,
1.293 meters per second, and this one was
4.83.
4.83 meters per second. Okay. And if I wanted to write those in vector notation, I could do that. So V1 has that magnitude, so V1 vector would be 4.83 meters per second times, and then how much does it go in the x direction? Let me introduce. This is the x direction. Y. So if it's that big and it's it's going in the x direction, then I would have 4.38 cosine 15 degrees x hat plus 4.83 meters per second sine of 15 degrees y hat, and that'd be the vector for V1. You know, if you evaluate that in V2, what would that be?
1.29 meters per second cosine of.
So this angle, if I drew the x direction like this angle here, because this
75?
has, yeah, 75 degrees. Okay. So V2 would be 1.29 meters per second cosine of 75 degrees x hat. And then it's in the negative y direction, so minus 29 meters per second sine of 75 degrees y hat. And you can evaluate those. Make sense?
Wait, where did those come from?
Where did this come from?
Yeah, how did we know to put
Oh.
those like
So if I wanted, let's take a look at it. If I want to write this, figure out what this vector is, I want to write it in components, right? I guess I could say, so this is
Gotcha. It's just the
75
components of
degrees
it,
here
okay.
because these angles diverge at right angles if they're the same math.
It's just the x and y.
What's that? Yeah,
It's
and
just-
so this part would be the magnitude of this cosine of the 75 degrees, and this part down here would be the magnitude of this times the sine of 75 degrees, and once in the negative in y direction. So that's where this came from. Does that make sense to you guys? All right. We'll do some more momentum conservation problems today.
So if we didn't all think to do it with the triangle thing, is there a different way to do it without doing the sign of it?
Well, the way I did it, let me show you how I did it. And believe me, it's more work.
Okay.
So I thought this was really, I mean,
Difficult. You thought it
I
was
thought
a hard
this was awesome.
problem.
So what I did is I wrote out the equations in gory detail. So V1, V2, okay, and then V initial. Okay, so I did is I conserved momentum beforehand. So before, the momentum before and the momentum after, and I have two components for momentum, right? So momentum. Px initial has to be equal to Px final. So the initial momentum in the x direction here would have been the m times that 5 meters per second. And that would equal the total momentum in the x direction finally, which would be m times v1 x plus m v2, the x component of the v2 vector. Make sense? And then I could write that in terms of vector, in terms of angles. This would be m v1 15 degrees, 75 degrees. I guess I haven't known that yet, but v1 cosine of 15 degrees plus m v2 cosine of 75 degrees.
Oh.
Okay? And that's m, and then I can divide through by the m's. So I get 5 meters per second is v1 cosine of 15 degrees plus v2 cosine of 75 degrees. Okay, now I'm going to do it in the y direction. Py initial is equal to the momentum in the y direction finally. Is there any momentum in the y direction initially? Well, I get 0 is equal to, then I'm going to get this, the part of this momentum in the y direction. So that would be m v1 sine of 15 degrees, and then minus m v2 sine of 75 degrees. And that's equal to 0. And I've actually already used my kinetic energy equation to see that, because I got these two diverging at a right angle. So now I have two equations and two unknowns. I have this equation here and this equation here. And I could divide this one by m, by the way. And then I could solve those for v1 and v2. So I think the triangle way was simpler. That's why I was very happy you guys realized that. So, but you'll have the right answer either way.
Yeah, you do, because I did it that way too.
Make sense? You want to do another problem? Yeah. Let's do some more momentum problems. These are good because they teach you to add vectors once again. So if you're having a problem with vector addition, which was the weakest problem on the test, so I know that people are, this is good practice.
It's probably going to be on the next test again.
What's that?
So this is probably going to be on the next test.
Possibly, yes. So, fortunately, it's one of those things that if vectors were confusing to you, at the beginning of the class and you didn't take time to learn them, you'll lose points, a ton of points all the way through. So, the only way to get over that is just to take the time it takes to learn it. However that is, and sometimes you have to learn how to learn. And, for me, a lot of it, I don't know if it's different than most, but I do not learn in groups well, because I'll either rely on people or things like that. I'm fine if I've learned it and teach it, that's better. That's great for me. But if I'm trying to work in a group to learn something, for some reason it doesn't work well for me. And so I've always had to kind of go away and hide somewhere for a couple hours and just kind of get it narrowed down, nailed down in my own head. And that's just, but probably everyone's different, but, that seems like that's the way that has worked for me and for most of the people I know. Something to consider if what you're doing isn't working. So let's do one more. Let's do one more. It's a momentum problem. Okay, this one is going to be an inelastic collision. What does inelastic mean?
The form of the objects are changed. Like,
Yep, and if it's completely inelastic, they're stuck together, right?
Mm-hmm.
I guess when we say inelastic, I guess we're talking completely inelastic, where they're stuck together. We'll each say that this is a 1 kilogram and then this is 2 kilograms. Okay, this is moving. So these guys move like this. This angle is 30 degrees. This angle is 60 degrees. And they each move at 5 meters per second. And they come up here and, you know, it's not drawn quite right, but, you know, they come up here and they hit each other. Okay, so then they glom together. M1 plus M2. Okay, what's the speed of this? What's the vector? Maybe I'll do it actually. I think it's more like this. What's the vector of this stuck together 2 clay balls or whatever these are? Imagine these are clay going off like that. So can you figure out the final velocity vector of these 2 balls after the collision? So I'm going to give you guys about 3 minutes, and should we get out whiteboards? Does anyone want to do this? Whiteboard wise? Okay, this first one we won't. I'll go get them out for the next one. But go ahead and give you guys a couple minutes to do this. Then I'll race you. Magnitude
So I can't use
I did just learn.
yeah, I want to try
It seems like you're in the right direction.
and it wasn't that way. That was like this last time initial velocity and then divided by the amount to get the final. Yeah, I'm gonna check. So you don't think? I don't think it's
Not quite.
well,
Massachusetts.
well, it's 10, so 15. That's like 15 divided by 3. Pretty good. What did you get? Travis, can I borrow your big eraser?
Yeah.
Gracias. Can you give it to me? Thank you.
No, no. Yes. That looks good. Good job to be able to understand.
Like what you guys It doesn't work. Like how can it work with it? Since no, I'm not. Since it's since I know I use it, I saw it on the back.
The momentum beforehand.
So you have to break it down.
Before the collision Yeah.
So, basically break it down into two equations. One for the x having
Well, it hasn't
y,
right.
and
Of this,
the other for
yeah.
Per second.
Also, like say N1 VI. So where do you add in the x?
so I broke it down into like just solving just find components for each triangle.
Yeah, for each.
Just figure,
So
just
I have
figure out
the-
the velocity.
So
Okay, so it's just a velocity vector.
yeah, you
So
can
like,
write
to
it.
find it for this, it's gonna be negative. Okay, so for this one, you got a no negative 5, so it's gonna be sine of 30.
Yeah. Okay, so sine of 30.
Big abstract.
This sine of 30.
So like this one you just drew is gonna be sine of 30, negative sine of 30 because it's in the y direction times 5 kilograms per second. That's what
Gives you
yeah, that's 5
because
kilograms.
1 times 5
Is
yes.
your
This is your
magnitude,
velocity.
it's multiplied times your mass.
5 yes.
Because so
5
that's
yeah. So it's
you're literally taking this and making
kilograms per
Now do the same thing.
meters per second. Yeah.
So momentum vector.
He told us you have to write 5 kilograms meters per second.
This has to have the same final
Yeah.
momentum.
Okay. Okay, so that
So
negative
the
5
total, and that can be
kilograms meters per
both
second times 30
components,
is
right? Like,
this. And then negative, no, not negative.
All right, you guys ready to go through this?
Yeah,
You have to break
yeah, I got it now.
Okay, we'll go through it. This one, I guess, is a little bit tricky.
and then you do it for this, so it's positive.
Yes, and then just big X hat and then that.
This is gonna be 10 kilograms. Because it's 2.
Yes. 2 times 5.
Okay. So I'm gonna look at the initial momentum, the momentum before the collision, and then I'm gonna look at and then that has to be the momentum after the collision. Okay? So the initial momentum has to equal the final momentum. And for inelastic collisions, that's all we need, and we just have to know that the final velocity of the two objects is the same, because they're stuck together. So, let's figure out the initial momentum. So I'm going to call this 1 and 2. The initial momentum would be the momentum of object 1 plus the momentum of object 2. Which would be m1 v1 vector plus m2 v2 vector. All right, so I have to figure out what those are. So I'm going to simplify my life a little bit. I'm going to call this mass m. This has mass 2m. Okay, and I'm just going to call the magnitude of these velocities v's. So 5 meters per second. V is 5 meters per second. And then I'm just going to do this algebraically so I'm less likely to mess up. So this is the initial momentum. This is what I want to do. So V initial, V1, what's that going to be? So these are vectors. So I have to split it up as a vector. So what would V1 be?
M V sine
And
How much of it goes in the x direction?
M V sine 30.
Or just for
Yeah.
V, just for V.
after V.
V cosine 30.
So this would be V cosine 30 degrees x hat, right? And how much of it goes in the y direction?
V sine of 30.
Minus V sine.
Minus V sine. It's good. It's going down.
Minus V sine of 30 degrees y hat. Does that make sense to you guys? You have to split it up into components like this. So how much of it goes on, how much of this velocity vector goes on the x and the y? That's what we did here. And so, how about V2? How much of that goes in the x and the y?
And it would be V
V cosine
cosine
60.
of 60 degrees x hat.
V cosine 60 degrees x hat, good.
And then plus
V
Plus V sine of 60 degrees y hat, good job. All right, now if I want to get the momentum P1 and P2, P1 is just m times this, right? M1 times that, which is just m V cosine of 30 degrees x hat minus m V sine of 30 degrees y hat. P2 would be 2m V cosine of 60 degrees x hat plus 2m V sine of 60 degrees y hat. So P total, P initial, which is P1 plus P2, what would that be? I can actually factor
Yeah,
it in.
yeah.
So I just add the x's together, right?
Mhm.
So it would be m, is it, am I making any sense?
Yeah.
I just add the x's together and then I add the y's together, right?
Mhm.
So I want to add those together.
I
Can you factor out V cosine? No.
What's that?
I did that, but I didn't get the right answers.
Oh, well, we'll see. I'm
Is that what you did?
I'm gonna factor out an MV from everything, okay?
Yes.
And then this would be, what would be left is in the x direction, I'd get a cosine 30 degrees plus 2 cosine of 60 degrees. And then in the y direction, I would get minus sine of 30 degrees
You just didn't divide by 3.
plus 2 sine of 60 degrees y hat.
So this one is,
Good?
this one's right.
So this is my initial momentum. Written out sort of in gory detail, although I haven't put any numbers in here yet. That has to equal my final momentum,
So this is
which is 3m
So you need to factor
v final vector. Okay?
you know how to do that with the momentum.
So if I wanted to get what v final was, what should I do?
Times V.
Divide by 3m.
So if I
So
take
you
this and divide
out
by 3m, it'll be
three.
there.
Yeah.
So if I do that,
For some reason,
So if you just like calculate in grams, and when you're calculating kilograms, I mean, momentum.
oh,
if I do that, I'd get,
this one's negative.
so I get
Yeah,
m
that's why.
So
V
that's why this one's off.
times cosine
This one's
of
negative.
30 degrees plus 2 cosine 60
You get a
degrees
different value for the.
Yeah.
x hat
Okay.
It'll be 6.6, I think.
plus, I'm just having to write this out because
And
I
then you would divide by the 3.
can't see it.
And then you have to-
Minus sine of 30 degrees
So you just
plus 2 sine of 60
So
degrees
that's the direction on that one, and then
y hat, that's
Okay.
3m v final. That's 3m v, okay? So that's this b. And so if I divide by 3m, what would I get? Yeah, I just can get rid of these m's. Three. Yeah, okay? That's what happens if I divide by 3m. Now I can evaluate, and I'm most likely to make mistakes, I think. So this is 5/3, 5/3.
PI.
Take that, put that in there. And what I got is 3, so in the x direction, I get that this is 3.11 meters per second x hat plus 2.05 meters per second y hat. Did anyone else get that? Yeah. That's good. You see what I did? I just wrote out the vectors and then added them up and for the initial momentum and then set that equal to the final momentum. Okay, that's all. You want to do another one?
Set the second both equals to each other. So,
Yeah.
I'll let you guys do a very, very similar one since that seemed a little rough.
wait, don't erase anything else. I'm working on it. Just actually, I just need one part.
Can I erase this part?
Yes.
Yes.
So P final is just 3MB.
Okay, we'll do another inelastic collision.
And then this is. So then you set those two equal to the other. So then you set these two equal to each other and
Divided by 3.
Okay.
oh,
We'll do something a little simple, okay? So, this has, both of these have the same mass, mm, okay? This moves at 10 meters per second at an angle of 30 degrees this way. And this thing moves at 45 degrees at an angle of 8 meters per second that way. These two things collide, and I want to know what this final velocity is.
So they're the same.
So,
Yeah.
Yeah, same mass.
Is that 40 or 45?
45. So can you guys go ahead and see if you can get that real quick?
Do we need to know the mass?
So you'll do the same thing that you did last time, with figuring out the initial momenta, which is mv, and set that equal to the final momentum of the combined object.
guess we'll go through this at the beginning of the day next time. It's a little,
I got V equal to 1.0 meters per second, X hat minus 3.55 meters per second, Y hat. I'll go check that one.
You got one of those?
Very good.
Okay.
see if you can get that.
Marissa, did you get that one?
I got 1.5 and 5.33.
Yeah.
So
Yeah,
last
the same.
That's what I got. I'll check my work again. That's it.
So,
You guys are so long.
Hey, I
Instead of
did
three,
make
it'll
a
be two.
mistake.
the two ends.
I did make a mistake.
Oh.
That's why it is. That's why it's 3.5. I think that's it'll be.
It'll be our fault. Right.
Oh, yeah.
So it should be 1.5 and 5.33?
Yeah.
Yes.
Okay, awesome.
Tell Marissa if you see her.
Oh, Jacob, we're gonna write our quick problem real quick because it's due tomorrow.
Where?
And I,
Meet me up there.
any other time? I was telling Travis I had an idea for a problem, and it was like what we did one.
We're gonna be in a
That's
different
like-
school, so we won't. Thank you.
We can't just do it like this.
So it's gonna be one with torques and all that stuff. So like if we did like, there's a beam
The one before.
and there is, there's a wire and there's this beam. There's gonna be there. Are you gonna be in our group for the problems or not? We're writing our problem. For the test, we have to write a problem in groups.
Test problems for the test.
Yeah, for Monday. He said it's due tomorrow, so. Well, if you were writing one real quick, if you wanna. So anyways, this is the okay, that's fine if you don't. We'll write it down and you can be in our group. Anyway, there's like gonna be a bear on this beam, and there's maybe what did we say, like honey or something?
Yeah, honey or a bat.
There's the mass over here, that's the beam, this is the wire. First we're gonna like find out the force.
So we'll know where
in the cable.
we'll know the distance of where the bear is at.
Yeah, we'll
and say,
give them
like,
distance and
we'll
all
say
that
like the
stuff.
bear is at this distance, how much is the wire? And then you say the wire actually has a breaking
much breaking
strength
strength
of
of
this
this.
much.
That's where he said like
Um,
plug this in right here.
How or at what distance?
Can the bear travel before this breaks? To see if it can get this. Like, will he be able to get it? If it, whatever distance, you know.
Okay.
And if you guys want, I can just like write it all out and bring it tomorrow. I just wanted to.
Okay, so this is.
Yeah. So this is the beam, and
Now,
it's gonna be a torque
if I have something
problem.
swing up
There
here,
and there's a wire holding this
the
whole thing.
velocity that
And this
begins
bear
with
is gonna
this
be
swing
walking
would be this.
along this beam, trying to get
Mhm.
something here
So,
that's
actually,
like
if I
I
think
don't know
about
goodies or whatever.
This V
And
is
then
V, or this
we're
is
gonna
V.
have them calculate the force here And then once they calculate, if
Cool,
this
okay.
has the braking
Yes.
force of this,
And then question
how
about
far
that
can the bear travel
was,
before this
Right
breaks?
here, is this,
I like that. I think it's really
Okay.
good.
when we broke it down,
That's-
so this is
We don't, we don't know if the bear dies or not.
for
Yeah,
both of them?
Yeah.
Okay.
it's up in the
All
air.
right, I'm done, thank you.
I just want to make sure I was on the right track with this last one. So
Just
this
say,
one,
can it safely travel to the end of the beam
with this
and
one,
not break
I
the...
took,
Yeah.
because it's going this direction, I took the other side of this and made like a 90-degree angle, so saying that this was 60
You
degrees.
can start out doing that, yeah.
Okay, so I took, so for V1, which is this one right here, I took the sine of 60 degrees in the x direction because it goes that far, and then minus the cosine of 60 degrees in the y direction because it's going
Yeah,
down.
that's good.
And so, and the only question I had was, this is the, like, yeah, so right here we had 3,
That'd be 2mv final, right?
see, that's what I was wondering about. Is that because there's 1m and there was 2 m's?
Yeah, because here the final thing was
Okay.
2m.
Okay, that makes sense. I was wondering if that was a constant value or if that was specific to each one. So it'd be 2m, and I just want to make sure the P initial looked right, so it would
Yeah,
be
that's
sine. Okay, awesome, that makes sense.
What do you mean, what